Hi, good morning, everyone. I hope all of you can see my screen.
Yes, sir.
Okay. So I will just start, and I have started recording also. So just to give you the brief introduction, this project or this problem I have taken from Kaggle. This is about our the famous Titanic mishap. The Titanic, RMS Titanic, it was a British passenger liner that sank in North Atlantic Ocean in the early hours of 15th April 1912 after it collided with an iceberg during our maiden voyage from Southampton to New York City. Now, there were an estimated 2,224 passengers and crew aboard, and more than 1,500 died. So, in this, we have been given a data set of the people who survived or did not survive, and we have to predict on the test data set based on the features. So if we see before coming to actual the data problem, I will just briefly cover a data science framework that what do we do in the data science. So first of all is we have to define the problem. And for defining the problem, we have to have some kind of business analytics. Thereafter, once we have defined the problem, we have to gather the data. Now the data can be given to us or we have to mine the data either from the clouds or from the databases, which has been adequately covered by Mitesh ji in his class in the coding nest. Thereafter, once we have gathered the data may be in different formats. So we have to prepare the data for consumption, and this will involve data wrangling, data cleaning. After that, we have to perform the basic exploratory analysis to know the relations of the features on the target level. And thereafter, we have to do the first basic, we have to model the data. And once we have modeled the data, thereafter, we have to validate, we have to tune the hyperparameters, we have to find the best model to find the solution either to the classification or to the regression problem. And thereafter, we have to implement the data model. And thereafter, we have to keep on, we have to go again to the first step, and we have to see that how much successful we have been. And thereafter, we have to optimize and strategize to find the best solution. So coming back to the this Titanic problem, it's a classical problem. It has to predict the outcome of a binary event. Binary event means either 0 or 1. It means whether that person survived or did not survive. So in layman terms, it means it either occurred or did not occur. It is like a coin toss, whether it is head or tail. There can be only two outcomes. So if we see in this binary events, the probability is always 50% for one event. So whatever our model is there, our prediction scores have to be better than 50%. It can never be less than 50%. Now coming to the first step of the data science, that defining the problem in this Kaggle project, the problem statement has already been given to us, and we have to develop an algorithm to predict the survival outcome of a passenger on the Titanic based on the features. The second step of the data science also in this project we don't have to do because already the data has been given to us. This data is available in Kaggle online site in the form of train data and the test data. There is also one submission file basically in which only the IDs have been given, and we have to fill our solutions in that to submit the file. Coming to the step 3, so already this data from Kaggle, it is already the data wrangling and everything has been carried out, and it has got a proper data architecture. Therefore, we don't have to do majority of the steps which are involved in preparation of data. However, we have to do certain kind of data cleaning because there are some missing values. So after these 3 steps coming, we to gather this data or to read the data, I have imported all the libraries. So if we see on my screen, I have imported NumPy, then pandas for visualization, the matplotlib as PLT, Seaborn, and for feature scaling, I have imported all the libraries which Mitesh ji had covered during his feature scaling meetup. For the scalars, I have imported min max scalar, standard scalar, and for shuffling, I have imported shuffle from sklearn.utils. In the models, I have imported majority of the classification models, starting from linear model, tree, neighbors, naive Bayes, ensemble, discriminant analysis, Gaussian process, XGB classifier, logistic regression. This I have done basically that I will use all the models to find out the best score so that we can find the best model for this problem. For splitting the data, I have imported the train test split for cross-validation k-fold, stratified k-fold, cross-val score, cross-val predict, and cross-validate. For checking the accuracy, I have imported classification report, confusion matrix, accuracy score from sklearn matrix. For the finding the best parameters, hyperparameters, I have imported the grid search CV from sklearn model selection. And there are certain common model helpers that I have imported: one hot encoder, label encoder, feature selection, model selection. And I have also imported the time, basically to find out the time when I will be checking the accuracy of various models, that how much time these models took. So after once I have collected the data, I have read the data into formats: train by reading the train CSV from Kaggle, and test. And I have also made one data combining this both train and test. Basically, if I have to carry out operations on both data sets, I have used this data. So to get the first feeling of this data, we see the train dot head in which we get the first 5 rows. So if we see, we have got passenger ID, which gives the ID of that passenger. The second column is survived, and it involves a value 0 or 1. 0 means that that passenger did not survive, and 1 means survived. The third column is P class, that is the passenger class. We see the values here 3, 1, 3, 1. The exact values we will find out later. However, what it denotes and what it gives us a feeling that it is giving us a class of that passenger, 1 class or 3 class.
Hey Lalit.
Hi.
Hi Lalit. Praveen here.
Hi, Praveen.
Yeah, I was looking on the import section where you have imported, all the libraries which actually useful for it for this project. I have seen there is one library that you have imported, which is linear model.
Yeah.
Right. So yeah. I believe this is a classification problem, and I guess linear model is for regression. So does
yes,
it?
Yes. So this linear model I have not imported for the classification. This linear model, once I will come to the feature selection, if you remember, Miteshi had covered one of the lasso and regression. So for that feature selection, I have imported this linear model. I hope I have been able to clarify your doubt.
Yeah, correct.
One more thing, Praveen sir, basically under linear model family, there is a logistic regression as well. And logistic regression is part of your classification. So that's why sir has, it can also be used for logistic regression as well.
Yeah, we can see that logistic regression has been imported from the linear model.
Right. Thanks.
Okay, thank you. So the fourth column is the name column. And if we see this name column, we can see, the last, the first name which is there, it is a last name. And thereafter, it is Mr., Miss, or Mrs. It is there. The next column is the male sex column, comprising of male and female. Thereafter, the age column is there. Then the next column is sibling support column, and which has got the values like 0 and 1. From the data set and in the Kaggle, it has been given the sibling support comprised basically of the values of the siblings or spouses accompanied by that passenger. So if we see for the first row, the 1, it means that passenger had one other spouse or the sibling support. Amplifications on this I will cover later on. The next column is Parch column, which is also similar to sibling support. However, it comprises for the parents and children that this passenger had, whether he was traveling with the parents or children, and these are the values which are given for that. The next column is the ticket column, and we can see the ticket numbers. There are some only numeric numbers and there are some alphanumeric. Thereafter, we have got the column of fare, means the fare for that passenger. The next column is the cabin. Now, if we see in the first 5 rows also, there are 3 missing values. The cabin denotes the cabin, the classes. It is also related to the classes, the cabins which are there. Later on, we will try to explore this column. The next column is embarked. Now, this Titanic ship, it started from Southampton and it went to Cherbourg in France. Thereafter, there was a port Q, and it was on the way of New York. So there were 3 embarked ports, that S, C, and Q. Now, similarly, I have gone to the test and I have used the sample function just to find the random rows. In the test, we see that the survive column is not there. Rest all columns are available. So if we see the data, for us, the target label is the survive label, and from P class to embark, these are the independent variables. Based on these features, we have to predict the survive. Now coming again to the data information, the survived column, like I have covered, it is the dependent variable and it is a binary nominal data type, 1 for survived and 0 for did not survive. The passenger ID and the ticket variables are assumed to be the random unique identifiers. The passenger ID is in a running state. The P class is an ordinal data type for the ticket class, which is a proxy for socio-economic status, representing that the P class 1 was belonging to the upper class, 2 to the middle class, and 3 to the lower class. The name variable is a nominal data type, and it can be used in feature engineering to derive the gender from the title, family size from surname, and socioeconomic status from titles like doctor, colonel, major, or master. We will be utilizing this column to take this information. The next column, 2 column, the sex and embark variables are a nominal data type, and they can be converted to dummy variables for mathematical calculations. The age and fare variables are the continuous quantitative data types. If we see, if the age is less, then it is in the fractional status. For example, you can see the minimum is 0.41. Thereafter, once it is more than 1, then it is estimated to 0.5 or to the complete numeral. The sibling support represents the number of related siblings or spouse aboard, and the parts represents the number of related parents or children aboard. Both are discrete quantitative data types, and this can be used for feature engineering to create a family size one more column is alone. Like sibling support comprised of the brothers, sisters, stepbrothers, stepsisters, and spouse, husband, and wife. The mistresses and fiancés, they were ignored in this. For the parent, mother and father, and for child, daughter, son, stepdaughter, and stepsons. So if we see this data, it means only in the sibling support, these many things are given, and in the parts this. It means if there was some more relative or you were traveling in a group, then that data is not there in this, and that we have to gather that data by doing the feature engineering. For example, if there was some children who were traveling with a nanny, then there was a part was 0 for them. The cabin variable is a nominal data type which can be used in feature engineering for approximation of the position on the ship. There was this passenger. And like I covered, this ship traveled from Southampton to New York via Cherbourg in France and Kew in Queenstown. Once I read about this ship online and I did little bit of research. On the basis of that, I found out that when this ship was sailing from Southampton, there were a lot of people, majority of the people, they were who were traveling to United States to find something. So they were like the migrants class, and there were also a lot of people, all the big shots of those times, they wanted to travel in this ship. Now coming thereafter, I have used the info column, and if we see in the info column for the train data, there are 891 rows. For the survived P class, name, sex, all the rows, they don't have any missing value. But when we come to age, we can see There are 714 only values are there, rest are missing. Similarly, when we come to cabin, majority is missing, only 204 values are available. And there are 2 values missing in embark. And if we see the data type, we see name and sex are object type. Survived P class name, P class and survived their int 64, sibling support parts int 64. Ticket is an object type. Fare is a float 64, and cabin and embark are the objective type. Thereafter, once we see the description of this train data, we can see the counts. For example, in age only 714 are available. We see the maximum and minimum. So this information is available for sibling support. 8 was the maximum, for parts was 6. The fare, if we see, there is a lot of difference between the maximum, that is 512, and whereas minimum was 0. So there is a huge difference in the fare. Thereafter, by using the dot describe include is equal to O, that is the object, I have found the description of the object types. So if we see in the cabin, only 204 values are available. Unique is 147, and the frequency of that is 4. Similarly, if we see ticket, there is a frequency of this ticket 347082 is 7. It means there were 7 passengers traveling on this ticket. Now thereafter, I have gone to find out the unique values or the range for this feature sets. So for the discrete, I have found that in the genders, there is a male and female. Embark, there are 3 and there are 2 missing values also. In the passenger class, there are 1, 2, 3. Survived has got 0 and 1. The sibling support, I have used minimum to maximum. So it is from 0 to 8. 0 was for traveling alone and 8 was the maximum sibling support. For the parts range for parent and children, it is from 0 to 6. And fare range, like I covered earlier, the difference is too much. It is from 0 to 512.3292. The 0 might be for the crew members who are traveling. And for age, the range is from 0.42 to 80. The minimum age was 0.42, maximum was 80. Thereafter, I have gone to find the numerical and categorical features using the same code covered by Miteji in the class. So by num underscore vars is equal to var for var in train dot columns if the train var data type is not object type. So if it is not an object, it has given us the, I found the names and the length. So we find the passenger ID, survived, P class, age, sibling support, parts, and fare. There are the numerical variables, and there are total number 7. Now out of this, again I have gone to find the discrete variables. So for the discrete variables, we have assumed that the unique values of this has to be less than 20. So by using the same code, I have found that survived, P class, sibling support, and parts, these are the discrete variables. And the age and fare, they are the continuous variables. Now after finding the numerical variables, I have gone to find the categorical variables using the same code, that if the cat underscore vars is equal to var for var in train dot columns, if the train var data type is equal to object. So by this we find out name, sex, ticket, cabin, and embark. These are the categorical variables. And thereafter I have gone to find the cardinality. So name is like for all 891 categories are there. In sex there are 2 categories, and ticket there are 681. Cabin 148 categories, and embark 4 categories, which comprises of S, C, Q, and missing values. So after reading the data and getting the first basic insight in the data, that how the data looks like, what are the missing values, we have come to the next major step that comprises of data cleaning. Now the data cleaning comprises of 4 major steps. The first is correcting, second is completing. Correcting means that if the data has got some values which are out of the range or abnormal, then we have to correct the data. Second is the completing the data. If it has got missing values, then we have to complete the data. The third is creating the data, that using the features, we create some new columns. And fourth is converting the data into the thing which the computer can understand. That is basically to convert that to the mathematical values by using either the label encoder or the one hot encoding, or by mapping, or by getting the dummies. So for the first step, for correcting the data, we know that there are two continuous values in this data set, the age and fair. So to know the distribution of these continuous values in both train and test, I have plotted the box plot, and by using the subplot, so that I can compare them along both are side by side. So I have plotted dot subplot 2 to 1, whereas 2 is the number of rows and 2 are the columns, and the first plot. So I have plotted for age, train age and test age, and thereafter I have plotted fair in the box plot. So what we see, these are the plots which are available. In the age, there are a lot of outliers above age of around 64. So we can take a call basically to discard these outliers. But when we go to test age, there are only 2 outliers and after age of 64 only. So if we remove these outliers, it means that my model will not be able to predict these 2 data sets. So these 2 observations. So we can take a call whether to keep these outliers or not. In my case, I have decided to keep these outliers. But when we see the fair, in both the train data set and test data sets, both comprises of lot of outliers after a third quartile of around 90. So both the data sets have similar types of outliers. Therefore, it is prudent to keep these outliers and not to discard them. In my case, for this, I have kept both the outliers in both age and fair. So with this, I have finished the first step, the correcting. Thereafter, we go to the next step, which is the completion, that is the imputation. Now, before we carry out the imputation, we have to see the brief insight into the relations between various features and the dependent variable, that is surveyed. So I did some data visualization to get some insights. So I've gone column by column. So when we see the first column, that is the surveyed, and which is the target level. So first I have found out the value counts. What are the total value counts? And thereafter, what was the percentage? So if we see out of our 891, 549, they were the values of 0, means did not survive, and 342 people survived. The percentage wise, around 61.6% people, they did not survive, 38.38% people survived. And the same I have plotted as a count plot. So we can see the 549 people did not survive and 342 survived. Now, thereafter, I have done the visualization first for the continuous numerical features, which are age and fair. So first we have to see their distribution, that how do they look like. So I have used the HIST plot, and first I have done for the age. So if we see the age distribution, the age distribution is, first of all, it is a right skewed. So therefore, like covered by Miteshji, that if it is a right skewed or left skewed, then it is prudent to fill the missing values with the median value. So we have to fill the missing values with median value. But another important thing, if we see in this distribution, that it has got 2 distinct parts in this plot. One from age of 16 to age of 80, which looks like this. We can fill this median values. And the second is from the age of 0.42 to the age of 16, which is of a different type. So before filling these values for the age, I will try to take out some information from the name, from that Miss, Mrs, Master. So I will try to find out these, how many people they were in this age group and how many were here, before I fill that missing values. Now let's analyze survivability vis-a-vis age. So for this, I have plotted the KD plot of the age column with first train survived is equal to 1 and for second train survived is equal to 0. So with this, I have plotted both. So if we see the survived column vis-a-vis age, the blue line denotes the people who survived. So if we see this plot also here from age of 16 to age of 80, the distribution looks like normal with the right skewed. But for the children from the age of 0.42 to age of around 12 to 14, the survival rate, the more people in this age group survived. So whereas this is opposite for the age group from 62 to 80. It means different age pockets, they had different survivability. So what comes out the first insight in this, that we can divide this age data continuous data type into the bin types or the packet types by dividing this, so that each packet helps us in the prediction in the test data. Similarly, I have done the distribution for the fare using same the HIST, and we see the same here. First of all, there is a lot of difference. The more distribution was in the lower fare, and thereafter, after around 100, the distribution first of all is right skewed, and there are very less values after around 150. So there were very few passengers in the fare columns from 150 to 500. Similarly, I have plotted for the survived by this continuous variable fare by using the same KD plot, and we see the same insight here. First of all, the maximum people, they were in the lower fare, but if we see the survived and the did not survive, we see the people who were traveling on the lower fare, they had very poor chance of survival. Whereas when we go to the higher fare, here we see the most of the people, they survive. So most of the people who did not survive belong to the very lower fare. Thereafter, I have gone for the visualization of the target label vis-a-vis discrete numerical features which we found out earlier. That is P class, sibling support, and patch. So first we do for the P class. Here again, I have first found out the values by value counts, there are percentage, and thereafter I have plotted the count plot for the P class. Thereafter count plot with the hue of survived, and thereafter the bar plots with the P class and survived. So we see 491 people, they were traveling in class 3. So out of 891, 491 they were traveling in the lowest class. The first P class, there were around 216 passengers, and in number 2 were 184. The percentage wise is 55% in number 3, 24.24 in class 1, and 20.65 in class 2. So I have plotted the count plot. We see the same depiction here. Visually we can see 491, 216 and 184. And thereafter I have done the hue of survived. So if we see, the red color denotes did not survive. So we see that in the P class 3, the maximum people, the values are more than 350, they did not survive. So here the survival rate was the worst for the P class 3. Whereas for if we see for number 1 class, the number of survivors is more than number of people who did not survive. So here the probability was higher. So we can easily come to know that the P class played a very important role in deciding the outcome of survived column. Here I have also done with the hue of male and female that survived. So this I will cover later on also, but when we played the hue of the male and female, so in all the classes we see the females, they had better probability of survival. So the more they survive in all the three classes. So what we can see that the class 3 had the maximum passengers, but the class 1 passengers had the best survivability. Now let's go to the next discrete column, that is sibling support. So for that I have followed the same. First I have found the values, thereafter the percentages, and then I have plotted the count plot, and thereafter with the hue of survived. So we find in the various sibling support 0, 608. 0 means that there was no sibling support, meaning that that passenger was traveling without any spouse or any sibling. So 608 they were in that column. Thereafter 209 with 1. Thereafter the values have decreased. With 2 only 28, with 4 18, 3 16, 8 7 and 5 5. The percentages, by just dividing this with the length of train, I found the percentages of these: 68.23 they were traveling alone, 23.45 with 1, around 3%, 3.15% with 2. Thereafter the values have decreased. The same has been depicted visually on the left. These are the values, and thereafter I, with the count, I gave a hue of survived. So when we find out, when we see this plot, the people who were traveling alone, the maximum of the people, that around almost around 400 people out of total was 608, around 400 and people did not survive, and only around 205 people they survived. So the people who are traveling alone, this share of did not survive is much higher. With 1, if we see the number of people survived, it is more than the people who did not survive. Thereafter the same denotation is there. So if we then, the same I have depicted by the bar plot. So bar plot, if we see, with the 0 the survivable percentage is less. With the 1 and 2 it has increased, that if you had 1 or 2 sibling support, the probability of survival was higher, but thereafter again it has started decreasing. It means that if you had like 3 or 4, your probability of survival has decreased. And for 5 and 8, if we see, it is almost 0, means that these people did not survive. Now similarly we have done for parts. First the values, thereafter the percentages, the count plot, then count plot with the hue of survived, and thereafter the bar plot. So here also we see in the part 678 people they were traveling alone. So if we see this from the part and from the same from the sibling support, we see that more than 600 people they were traveling alone. The percentage wise, 76% without any parts, then 13, and gradually it has decreased. This is depicted visually on the left plot. And here, if we see, when we give the hue of survived in this count plot, we find the same insight, that the people who were traveling alone, here in this case also, almost around 440 people did not survive, and only around 230 people survived. So the ratio of not survived is much higher than all other columns. So this, it has given me the first insight that traveling alone is one of the main feature. So we can make a new column of that is alone, because here if you're traveling alone, then it has got a huge effect on the survive or not survive. Similarly, if you have got 1 or 2 sibling support or the parts, then your survivability has increased. So we can make a new column by combining the sibling support and parts, like a family. In my case, I have made a new column family by combining all this. So what we have seen after this visualization, that most people who were alone, they had less survivability, and we can combine these features in one column family, and for alone we can make a new column is alone. Thereafter, I have gone for the visualization for the categorical features, which is name, SATs, ticket, cabin, and embark. So if we see the name, it has got 891 unique values. So there are different names for all the passengers. From the name only, what we will try to do, we will try to take out the some insight of, first of all, sex, because we know that sex is playing a major role. And thereafter, we will also try to get some insight into the age by finding the title, like Mr. and all that. So visualization I have left out because there are 891 values. Then we come to get some insight into the sex by visualization. So I've done the same thing. First of all, the value count, thereafter the percentage. Then I have done the count plot, and with the then count plot with the hue of survive, and then bar plot with sex and survive. So we see out of total 891, there were 577 males and 314 females. So 64.75% were male and 35.24 females. The same is depicted on the topmost left plot. And when we see the same count plot with the hue of survive, which is there on the right top, we see that in the male, almost than more than 450 males, they did not survive, and almost only around 102 to 104 males survived. Whereas in the female, out of total 314 females, only around 80 to 90 females did not survive, and more than 210 females survived. So it gives us a fair indication that the probability of survival for female was much higher than the males, which I have plotted by the bar plot. If we see for the males, it is around 0.2, whereas for the females, it is more than 0.7. Now, after this, I have also done by the bar plot for sex and survive the same plot with the hue of embark. So this gives an indication with the ports. The first has given us the plot with the embark with the hue, the second with the passenger class, and third with the sibling support. So if we see for the embark, these are the three codes: blue for the Southampton, C for Cherbourg, and this is the Queen's. So if we see for the all three, the female survivability is higher than males. So in all the embarked ports, the female survivability is higher. The same goes for the passenger class also, that in all the passenger classes, the survivability of the females is higher. But we can see here in the males that in the passenger class one, how the survivability is decreasing. In the first, passenger class was the highest, thereafter passenger class 2, and thereafter 3. And the same also I have done for the sibling support. So with the sibling support also, we can see the females had more survivability than the males. Thereafter, I have gone to the next column, that is the ticket. Ticket has got 681 unique values. It means that there were total 891 and there is no missing value, and there are 681 unique values. It means there were a lot of people who had the same ticket number, which means that they were either traveling in a family or in a group or in a company. Now for the next column, we come to cabin. So first we see the unique values. It has got only 147 and 687 values are missing. So now here we have to take a decision whether we have to drop this column or we can make out something from this column. So what I did before going to that, here I have dropped this, that I am in the process of visualization, so we are not visualizing anything. But in this, we can see that 687 values are missing. So this I will explore later on. I have gone to the next column, which is embark, for which I have done in the same way, in which first of all I have found the values, thereafter percentages, thereafter count plot with the hue of sex, thereafter with the hue of survive, and thereafter the bar plot. So we see 644 passengers, they had embarked this ship from the first port, which was Southampton. Then from Cherbourg, 168, and from the last only 77. So around 72% they embarked from Southampton, 18.8 from Cherbourg, France, and only 8.6 from the last one. The same is depicted visually on the left plot. And when we have given the hue of surveyed, here we see that out of total 644 passengers who embarked from Southampton, on around 440 passengers they did not survive, and only around 205 to 210 people survived. So here, if we see, the survivability ratio is very, very poor. But for the passengers who embarked from Cherbourg, France, the more number of passengers have survived than did not survive. And for last port, it is not so much of difference like the Southampton. Now the same thing I have done for the bar plot. I have plotted for the embarked and the survival with the hue of sex. So if we see for all the passengers from all the three ports, the number of survivals or the probability of survival for females is much higher than passengers. So it is coming out very clearly that sex played a very, very major role in deciding the outcome of that column survived, because more number of females they survived. This could have been due to the ship's policy of helping the females earlier than the males. So the same, now after seeing all these plots, I have gone to make a point plot of with the X column parts Y survived with the hue of sex. So if we see in the females, in all parents and child also, the female survival is much higher. The number is higher. Next, I have plotted the hist for age with the row of sex passenger class with the hue of survived. So here also we get the same insight that the females they had higher probability of survival. Now, after getting this visualization I did before the imputation to get the first insight. So how to carry out the imputation and to fill the missing values. So now I have come to the main part, the imputation. So I have to fill, first of all, in the train, there are age column is missing and total 177 values. So using the same code which Miteshi had covered in the coding nest, I found out the variables which have got missing values in train, and thereafter I have done the visualization. So by the same code, that varies with the underscore NA is for where in train dot columns, if the train where is null sum is more than 0, print the missing values in train data where total train where is null sum. So I get age, there are total 177 values missing, which is around 19.9%. For cabin, 687 values are missing, 77.1%, and embark only 2 values are missing, which are 0.02%. And if we see visually by a heat map, we can see how the values are missing. We can see the majority, the cabin values are missing, thereafter age, and only 2 embark values are missing. Same thing I have done for the test column to find out. In the test, around 20.6% values are missing for the age, which is very similar to the train, 19.9. In here, there are 1 value of fare is missing. And for cabin, around 78.2, which is similar to the train data. So we have to remember that we have to fill this fare value also in the test data. The same is depicted in the heat map plot. You can see the cabin maximum values are missing, thereafter age, and 1 value of fare is missing. So again, I have plotted the hist plot for age, and the same insight that it is a right skewed and it has got 2 distinct parts. So we have to fill with the median values, but it has got 2 distinct parts. So we have to find out, we have to take some insight from the name column how to fill it. And again, to fill the fare column, it is a right skewed. So it is better to fill it with the median value of that 1 observation in the test data set. To fill the embark, we found out that from Southampton was the maximum passengers. So it is better, it is a categorical data. So it is better to fill it with the most frequent, that is the Southampton, that is the S for that. Now for the cabin, we found out that out of 891, 687 were the missing values. So these are, a lot of values are missing. So I decided to fill this missing value with one value called H, because when we see the train cabin unit which are there, it is, if we see, it is from A, B, C, D, E, F, G, and there is one T also. So I have thought of to fill the missing values of H, and it has given me one first basic understanding that if we see when we travel, in a train or on a bus, these are something like this is some class and this is a ticket number, or this is a cabin number. So this A, B, C, D, E, F, G, H, T, these are some classes denoting the passenger class that. So missing values, they could be for the people who are traveling, without any cabins, the crew members. So I have tried to club all these people in one value called H. So that is for the imputation of cabin. Now, like I covered for the age, I have tried to take out some insight from the name. And for that, I have used the string dot extract method of Panda series, by which if we saw the name column, the last name was there, and thereafter the title was given, and thereafter followed by dot. So by using this string dot extract, I have taken the title of all the names. So when we see in the train, the titles are Mr., Mrs., Miss, Master, Don, Rab, Doctor, Meme, Miss, Major, Lady, Sir, Melee, Colonel, Captain, Countess, and John Key. And by using the cross tab pandas method, I have found out the title and the sex. So for all this, for captain value was 1 only, and he was a male. Colonel were 2 males. Countess was a female. Don was a male. Doctor is 1, where there was 1 female and there was 6 males. John Key was a male. Lady definitely a female. Major 2 males. Master 40 males. So by this, I have found out the relation between the title and the sex. Like we know that sex played an important role. Same I have found out for the test also. The test, if we see the 2 colonels, 1 Donna, she is a female. Doctor here, he is only 1 male. So what I've done, I have replaced this and I have clubbed this into only one group by using the mapping. I have done the mapping Melee for Miss, Major, Mr. All the males who were there, I have clubbed them to Mr. And Master will come in for a child. And similarly, all the females who are there, like Lady in a Mrs., Countess in a Mrs., Donna into a Mrs. So I have done this replacing for both by using the data which comprised of train and test, by replace method, and by mapping. So when we see for the train and test, after this, we find that there are only 5 discrete values, that is Doctor, Master, Miss, Mr. and Mrs. So it has given me a new insight. First of all, I have found for the children, by seeing the age distribution, it had a definite. Second, the sex has played an important role. So by this, I have done that. So now I have to fill the age by using this insight. So I defined this titles, Doctor, Master, Miss, Mr., Mrs. For data set in data, for title in titles. So I've used the titles. Age to impute is equal to dataset dot group by title and age dot medium and titles index title. So by using this code, I have filled all these by the median values, which gives us a much better filling method for the age column. Thereafter, embarked, I have filled by the most frequent, which is the S, by fare by the median value, and cabin, like I covered, I have filled by using all these by the fillna method by H. Now next column, I come to the ticket. So ticket, if we see, like we found out earlier that there were total 681 ticket unique columns. So by making the pivot table for the ticket, we found out the values, the number of tickets for the passengers. So there may not be a correlation between the ticket and survival, but we know that only 681 tickets were there. And when we see for the people who were traveling with the sibling support or with the parent or for the children, their survivability increased with the numbers of that sibling support or with the parts up to 2. So same here, there might be some people who were not related by the sibling support or by parent or children. But if they have got a common ticket, it means they were friends or they were traveling in a group. So we will try to utilize this ticket column to find out those groups, because we know that that plays a major role in finding the outcome of the survived column. So after doing this imputation, again, I have checked whether there is any missing value. So by this, we find out for data set in data, print data set dot is null dot sum, and we find out that there is no missing value now in both print and test. Now we come to the next step in that is the creating, that is the feature engineering, that we have to make the new features. So like what we found out earlier for the sibling support and patch, I have made a new column. I have done the same visualization to get the same insight. So what I have done, I have made two new columns. For dataset in data, I have made a new column, dataset family, comprising of dataset sibling support with dataset patch plus 1. Because for all the people who are alone, it was 0. So here I have done plus 1, means that if it is 1, and then the numbers will denote the number of sibling support of the parent or children. I have also made a new column is alone, and I have initialized it that new column is equal to 1, and thereafter I have used the LOC method, that if dataset family is more than 1, then it is 0. It means all the people who are alone, they will be 1, and whenever they have got a family support, that here family is more than 1, then it is 0. So these two new columns we have made from the sibling support and the patch. Now we come to the cabin. Like I covered cabin, that it was from A to A, B, C, D, E, F, G, and then T. So here I have defined a new method just to take the first that alphabet from that cabin number. And what I've used, just first index of the cabin, because alphabet we knew that it was in the first index. So for dataset and data, we have applied the same, and we have found the unique values are same. H of the maximum, that they were for the missing values, and thereafter A to G, and there was one value of T without any number. Now for making age and fair bins, like I covered earlier, that age, it had distinct part. Similarly, the fair bins also distinct part. So again, I have gone to the same PD plot to make out that, and we have found the same, that for the age, the survival was different for the different age groups. But if we see, it is a similar to our Gaussian normal distribution. Whereas in a fair, we see there is a lot of difference between the people who were traveling in the lower fare than the higher fare. So when we have to make the bins for this, if it is a normal Gaussian, then it is better to use by the equal number. And if it is a right skewed or left skewed like this, then it is better to make the bins with the frequency. So there are two methods in pandas. One is called Q cut. If we do the Q cut, then it cuts on the basis of the frequency, which I've used for the fare. And there is normal method called cut, which is for the value bins, that I have used for the age. So for dataset in dataset fair bin, I have made a new column is equal to pd.qcut dataset fair, and I have decided the number of bins 5. Similarly, for age bin, I have done the simple cut, and here also I have 5 and S type int. So when we see the train fair bin unique, these are the values. It has gone from minus 0.001 to 7.584, then 7.584 to 10.5, 10.5 to 21, denoting the equal number of fares in these ranges. For age bin, it has gone From 0.8 to 16, 16 to 32, 30 to 48, it is for the equal numbers if we see. So here we have made two more columns in the feature engine. Now, like I covered earlier, that we can see the people who are traveling either in a family, but without those things, that sibling support or the parent or children. That means that if somebody might have been traveling with a niece, but it is not a sibling support. And similarly with a group, if you are traveling in a group on that ship, the probability of survival was high. So what I have tried to do, I have tried to use two, three things to know, to get that insight. Number one, I have tried to use the last name, that is the last name of that passenger was same. And if fare is same, it means that these two passengers or these two or more passengers, they were traveling in a family. So by that, I have tried to get values of, to make a column of family survival. And thereafter, by using the ticket, that if the ticket was same, then I have tried to find out the people who are traveling in a group. So like, so what I have done, I have used, first I have tried, extracted the last name from all the passengers by using the string.square, and we know that the last name was first and followed by a comma. So from here we have got all the last names. Now, like I covered earlier, this is a classical binary problem where the probability for both the events survived or not survived is 0.5. So I have made a new column for both. First of all, I have made a new data set by appending test to the train, so that I carry out the these functions on both for the train and test simultaneously. So for this, I have made a new column that is called family survival, and which is 0.5. That I have assumed that for every passenger, the survival value, the default value is 0.5. So for all of them, I have made a new column given family survival is 0.5. Thereafter, carrying out the first thing like I covered, that if the last name is same and that those passengers, they have paid the same fare, so it gives me an insight that these people belong to the same family. So for that, what I've done, I have done the group by the last name and fare. By this group by and last name, I have got group and group underscore df, that is group is this, and for group underscore df, which is this. So if the length of this group underscore df is not equal to 1, not if it is equal to 1, then it means there is only one last name or common last name but with different features. So in that case, this will not be equal to 1. But if it is, that will be equal to 1. But if it is not equal to 1, it means those passengers, they are traveling in a family. After that, on this group underscore df, by using the iter rows, I have tried to compare those passengers that what were the survived column outcome. So if we see in the train, we have got all the target label data is there, either 0 or 1. In the test, it is missing, so it will be a nan value. So when we compare by using, I have found the S max for the group underscore df drop ind survive.max. That if, for example, if we had 3 passengers and their last name is Abbott, traveling on the same fare. So one by one for all the passenger, I have gone and found the S max of the entire group here. So for example, the first Abbott, the survived was 1, and rest values for Abbott 2 was 0, for Abbott 3 was from test, it is nan. So for Abbott 1, I have dropped first and found the what is the survived maximum of the remaining. So if it is 1, the remaining values are 0 and nan. So this will become a nan value, and S min will also become a nan value. For the second, when I will go, I will drop 0, 1 and nan will remain. So again will come nan, nan. But for the third, I will drop the nan and the max will become 1 and S min will become 0. And thereafter, if the passenger ID is same as this passenger ID of this row, then I have family survival, I have made it to 1. Or if it is not there, then I have made family survival is equal to 0. So by this code, what I have done, first of all, I have given a default value of family survival of 0.5 to all, because 50% is survival, 50% not survival. Thereafter, I have got some insight that if this guy is, or this person is traveling in a family, then his survival rate will increase, because we have seen from the data. So family survival, we have made 1 and we have made 0. I will request everyone that you when you execute this, you execute line by line, so you will get what is happening in this. Like I've covered, I don't have a visualizer here to draw, otherwise I would have drawn. So when you make it step by step, you will arrive here that how this relation is happening. And for this I have done for both, for train and test, by combining in the data df. So if we see, after doing this family survival, we see that out of total test and train, the survived is not available for 418, which is a test data, but all the family survival values are available now. Either they can be 0.5, 0 or 1. So for each passenger, by just knowing whether he was traveling with a family, we have given a default value, knowing if we did not have, then 0.5, if he had, then 1, or if he did not have, then 0. So how it looks, the data df looks like, what we have made the new columns, we have made the new column family, we have made, the title has come, family has come, is alone has come, fare bin has come, age bin has come, the last name we extracted, and family survival, if we see, either it is 0.5, 0 or 1 will come. Now the same principle I have applied to find out the group. Now group, for that I have used only one function, that is group
Yeah, hi guys. I think Lalit sir has dropped, so just give him some time. So he will be joining in shortly. Yeah. I hope today's session is more useful. Actually, he's explaining us that complete data science life cycle. So he started with that EDA activity part of it. Then he moved to that feature engineering, feature selection part of it. So he just basically trying to start that feature selection part of it. So he has done that feature engineering. As we discussed it earlier, there are a number of steps in that feature engineering part of it. As he mentioned, like 4 C's. So these are basically like imputation part. Then we do that encoding other part like label encoders. Then he has done that discretization part for those fare and age column. Again, he has looked for that outlier detection, but there is no required for that outlier detection in the case of age and fare. So that's how he then moved to that feature engineering. Then he extracted a lot many features out of it. So using that parents and children and that parents and children. So he extracted a few more features over there. Yeah.
I Mitesh, I sorry, I had got disconnected.
No problem, sir. I will make your host. Yeah.
Okay, thank you so
Yeah.
much.
Done, sir.
Okay, thank you.
Yeah, we can see your screen, Lalit.
Okay, thank you. I'll just start recording before I start. Okay, recording is on.
Yeah.
Okay, so by using this, what I have done, I have found out about the people who are traveling in a family and in a group, because we know that there is a certain relation between that if you're traveling in a group or family and the outcome of that survived call. So again, I've gone to find out the info. So we see that we have made these certain new columns: title, family, is the loan, fair bin, age bin, and family survival for both. And data looks like this. So here, if you see the cabin we have filled with the H value, title we have got for all the 5 things. For family, there is a numbers, is alone either 0 or 1, fair bin, age bin, family survival. So now the last step is the converting. So in the converting, for sex, if we see the values are either male and female. So for that, I have just used a simple replace method, male and female, 0 and 1. This can also be done by either using the mapping or by using the dummies also. For rest all, embark, title, age bin, fair bin, and cabin code, I have used the label encoder. So I have made a new columns embark code. From the embark, getting the label dot fit and transform, title code for title, age bin code from age bin, fair bin from fair bin, cabin code from cabin. So if we see the columns now, what we have got the new columns from the original title, family is alone, fair bin, age bin, family survival, embark code, title code, age bin code, fair bin code, and cabin code. So now what we can do, we can drop these columns which are not required, because here the maximum insight we have got and maximum feature engineering which I could thought of, I have done. So I'll drop the passenger ID. Thereafter, I will drop the columns from where I have got some insight and which are not required no more. For example, we have got the name, so that name we can drop off. Similarly, this sibling support, and from parts we have made new columns, that is family and is alone, so they can also be dropped. So what I've done, uh, I've kept the original data in the train and test, and I have made train dot underscore orange and test underscore orange by dropping passenger ID, name we have got inside, age and sibling support already we have got, sibling support and parts we have got. From age we have made the age bins and that code also. So both age and age bins, they can be dropped. Already we have got the insight. Now it is not more required. So I've dropped. From fair, we have made the fair bins and fair bin code. So both fair and fair bins I've dropped. From cabin, cabin code has come. So cabins I have dropped. Similarly, embark code has come, and title code has come. So these things I have dropped. So if we see, around 10 columns are remaining. 11 columns in the train column, and in the test 10 columns. Hereafter I have come for the feature selection. So here we have dropped, we have made some new features by doing the feature engineering, and these are the features, and we dropped the features from which we got the insight and they were no longer required. Hereafter I have come to the feature selection, and only for the demonstration purpose, what I have done, I have gone through all the steps which are covered by Miteshji in his meetup group. So just to cover for all the participants. So first what I have done, I have made the x underscore origin and y underscore origin independent variables and dependent variables. I have split it, and thereafter I have done the splitting by using the train dot test split method in a test size ratio of 0.3, by which we have got x underscore train, x test, y train, and y test. So first method which I have used by feature selection using the constant features by using the variance threshold. So when I have kept the threshold is equal to 0, and I have fit that on x underscore train. So that by that, when I have got the get support in that, we find that the 10 features are available. This constant features has not recommended any feature to be removed. Thereafter, I have gone up for the quasi-constant feature method by which the threshold has been made to 0.01, and here also it has not recommended. All the 10 columns are remaining, so no column has been recommended or has been removed by this method. Next, I have gone to the correlation method, which is the filter method. So by which we have found the correlation between all the columns, and here also, but in the correlation, it has not recommended, it has not given any correlative features. So there is nothing to be removed by this. Then I've gone to the next method to check the multicollinearity with the variance inflation factor. So here, when I did this, when I used the same code as given by Mitesh ji, I found out the P passenger class and the title code and the cabin code. These were the three which were giving me more than 10. Here I remember from that class, from that meetup, Nitesh had covered that if it is more than 10, then try removing it and try to find. If it is more than 10, then these columns have got a multi-collinearity and it is better to drop it. So here, again, I dropped cabin code and title code from here. And after dropping this cabin and title code, these are the remaining columns. So then I check the accuracy on the original and after dropping by using the function of random forest classification. So there I found out that in the original, the accuracy was around 90%, 90.2 and 90.3. And after dropping these columns after the VIF, on the result, the accuracy remained 90.14, for which I have used the ROC AUC score. And on the test one, it decreased to by around 1%. The next method is the wrapper method. By it has got two. One is the step forward and second is step backward. The step forward I did, so it recommended, it kept these codes, and when we see it has not removed any code. Then I did the step backward feature selection. It removed embarked code, age bin code, and cabin code. So it kept around 7 columns and removed 3. Now again, to check accuracy after removing these columns, I found out that accuracy on both train and test had reduced by around 1%, 89.3 and 89.8. Then I've gone to the exhaustive feature selection. By using the EFS, it takes time. So it gave me the columns to keep passenger class, sex, family survival, embark code, title code, and recommended to remove this family code. When I remove this and check the accuracy, Nitesh ji, am I audible?
Yes, sir. You're audible.
Okay. I thought there's some problem in my end. Oh, okay. So after removing this, again, I checked the accuracy score and I found out that accuracy score from the original had decreased by around 1%. Thereafter is the regularization method. So if you see,
Yeah. Hi, Lalit sir. I think there is some issue. I think there is some issue now.
Embedded method. So the columns which are recommended, all were recommended method. All those methods the inside, and what I've judged and what. Okay, I can hear you, Nitish ji.
Yeah. Now it's better. Yeah.
Okay. Nitish ji, can you hear me now?
Yeah. Better now. Yeah.
Okay. So just for the basic demonstration purpose, I had kept all these steps, and I went through all the steps as covered in the meetup by Nitesh ji, and all these different they gave me the different recommendations for the columns to be removed. So I have taken the VIF method, that is a multicollinearity, and I removed the title code, cabin code from the train origin. So out of 10, I have kept 8 columns, and then I went for the modeling of data. So then I splitted the data in train and test. In the test size score of 0.3, the shape is 623, 8 columns, and for the test 268 and 8 columns. Thereafter, for the standard scaling, I have used the standard scaler, in which for the X-train I have fitted transform and X-test transform. Now after this is the final step wherein we have done the feature engineering, we have encoded, we have kept now the columns, we have done the standard scaling. So here now with these new columns, again I have just gone to find out the relation with the target label. So first I have done the exploratory analysis with the statistics, just by using the statistics column and to correlate with the survive column. So these are the final survival correlations with the peak passenger class, with the sex already we had done, with the family, which was a new column. So here we have got a different correlation now. Is alone, we can see around 50.56% if you were not alone, then your survival was lesser, and if you had a group, then your survivability increased. Similarly with the embark code, age bin code, and fair bin code. And the same I have done the visualization for all these new columns. Now the third last part comes the modeling of the data. So for this modeling of the data with these columns which I found out, and with these no columns I have found out the relation also. Now for this I have used the various classification models. I have grouped them in a machine learning algorithm. So in this I have got the ADA boost classifier, bagging extractive classifier, gradient boosting classifier, and random forest classifier as covered by Miteji in the last class. There is also a Gaussian process classifier given on NAT. There is a logistic regression, passive aggressor classifier, rich classifier, SGD classifier, perceptron. So this all I imported, and then using the same code as given by Niteshji, that print score this. So for all these classification methods, I checked the accuracy, which gave me the accuracy, which gave me the confusion matrix also. So for all these, I got the scores. So this helps me. There are two ways of checking the score. Either we can write a function where we get a score. I'll just share it with you. This is, I got, so by this we can get the score. But Miteshji, this code, it helps us also to find out the score of precision and recall. For example, some model might give us a very high score, but when we go in precision and recall, we find out one of the recall or one of the precision is low. So it is better to check. So this code of Miteshji, it helps us to find out the classification report along with the confusion matrix. So classification report, it gives us the insight into the precision and the recall. And hello, Miteshji, am I audible now?
Yes, sir.
Yeah.
Oh, okay. So this was the code which I used as covered by Miteshji to find out the classification code and confusion matrix for all these models. Thereafter, just to compare them and in a table by table, this is a code which is very, very similar to Miteshji. It is only I have made a new columns, and I have done the comparison of these codes with the accuracies. And I have done for both the train data when it is fitting, and second for the test data once it has been checked on the test data. And I have also used for the time, that how much time that data took, that model took. So if we see after comparison of all these models, I have also included the model parameters. What is the train accuracy mean? What is the train accuracy standard deviation? What is the test accuracy, and what is the MLA time? How much time does it take? So I'll just go to the code.
Meaning this one you are applying all models, sir, here?
This I am not applying on the model. This I am applying on the data of all the models. See, I'll just tell you. This is the group of all the classifiers.
Okay.
This is the code which has been covered by Miteshji, which gives us the classification report, it gives us the accuracy, and it also gives us the confusion matrix. This code is also doing the same, but it is not giving us these details. It is not giving us the precision, recall, and everything. But it is giving us only the comparison. I'll just cover it okay, one by one. So I'll just cover. For example, the CV split is equal to 10. Thereafter, I have made a new table that MLA underscore columns with the names MLA name, MLA parameters, train accuracy mean, train accuracy STD, test accuracy, and the MLA time. And what I've done, I have made the data frame from this, and the name is MLA underscore compare, PD dot data frame columns is equal to MLA columns. So this data frame has become MLA name, MLA parameters, train accuracy, test accuracy, MLA time. Thereafter, I've done row index is equal to 0 for L in MLA. MLA is what? All these classifiers. So it will take one by one. So it will go to first classification method. MLA name, how he will fill? He will take L under class name. So what is the name? That classifier name will come here, MLA name. So if we see for first, it has taken the, for example, SVC. It will do one by one. Thereafter, MLA compare dot log row index MLA name is equal to MLA name. So I have filled this MLA name to this MLA name. MLA compare, MLA parameters, it will take from this LG get params. Every classifier has got a get params. So it will fill by using this by getting the parameters. Then the CV result, then we have used the cross validate. This is the classifier on the X train, Y train, and CV cross validation is equal to 20. So from here we have got the CV result. MLA underscore compare this data frame. I filled this MLA time. The CV result when it comes, it also gets the fit time. That how much time did it take? So this MLA time it fills with this fit time. That how much time did it take to fit it? Thereafter, train accuracy mean, it will give the test score that on which I tried X train and Y train. It has given the test score. So this is the train accuracy mean. Train accuracy STD, it has given the same test score STD. Test score STD, it has come here. Thereafter, I fitted this classifier on X train and Y train. And what I've done, accuracy score of Y test and predict of X test. So here we fitted and we found the train accuracy, and when here we got the accuracy score and we filled it with the test accuracy. Here we got for the test data. So what it has done, that it is given in the condensed form, and what I've done by sorting the values, ascending is equal to false. So here for the train accuracy, it has given the models one by one. So best accuracy of the train is coming for SVC, but still we should, what I say, we should use this code as given by Nitesh ji, because many times this train accuracy may be higher, but we have to see the precision and recall, because here these values may be lesser. So we have to find where that model is giving results for both precision and recall based on your classification. So by seeing this we see that for the train accuracy, the best score is given by the support vector classifier, whereas for the test vector, data, the best accuracy has been given by the gradient boosting classifier. So this is the first thing where we got an indication that for this, with these columns, for this problem, which might be the best model. So this is the first indication. So SVC and gradient boosting classifiers are the two models which I found by this, that they may be of use to me. We can visualize this data frame by using this code, just by plotting the bar plot and X level and Y level for both train and test. So here the scores will come. We can see the same thing. Now I have got an idea that SVC is giving me the best results for the train data and gradient boosting classifier for the test data. So what I do, I go one by one and I tune the hyperparameters now for both of them, and I find the results. So for tuning the parameters of SVC, SVC is equal to svm.svc, the grid estimator. This is the standard for the SVC classifier for the param grid. So these are the params I have found that I will try for C from 1, 2, 3, 4, 5. Gamma will be the grid ratio. Grid ratio I've defined 0.1, 0.25 up to 1. Decision function type either OVO or OVR. Probability true, random state is a grid seed. Grid seed has come from 0. So once I fitted this, so it has given me the best estimator. The best estimator is what? That C is equal to 1, decision function shape is equal to OVO, gamma 1 probability is equal to 2, and random state is equal to 0. So using these hyperparameters for the SVC, I defined SVC model. I fitted on X train, Y train. I found out the Y pred one for X train, and thereafter I used the Y pred on the X test, and then I got the scores for both for the training and testing. So what I was covering earlier, if you see the SVC, I have found the best hyperparameters, and I've used the same code of Miteshji. The accuracy score is coming around 85.23. However, if we see the recall for 1 is just 0.71 and giving us an indication that it is not so good. Similarly, this is for the train and this is for the test data. In test data, it has further decreased to 0.70. So this is not such good. So I will try to do with a gradient boosting classifier. The second one, which has given me the better results in the test. So again, I have imported the gradient boosting classifier. This is the p-test 3 learning rate. These are the tuners and estimators, and I have used the param grid, and it has given me the best estimator with a learning rate of 0.005, max step 4, max features square root, n estimator 750, random state 10. So by using this, the same code of Miteshji, I have done fitted on X train, Y train. I predict on the X train, thereafter I have predicted on X test, and just check the results. Now, if we see on the train data, recall score has slightly increased, and the score is also higher than the SVC. On test data also, the accuracy score is 83.58% and the recall is 7%. So what I did, I found out that this gradient boosting classifier is giving me better results than this SVC. So I predicted the test data of Kaggle on this and I submitted. So on submission, I got a score of around 0.7923. And this was my final. However, after one day, I just kept on pondering. And then I was researching on net also. And then I came across a blog by one guy. And he had written that, what can be the relation between the embark code and survive? And really, it gave me an insight that, yes, that how did it matter that the passenger, he traveled from Southampton or he embarked from Cherbourg or from Queens? How did it matter? So I just did a hit and trial, because if you see, the sex is mattering, the passenger class is mattering, that where that person was there on the ship, it was mattering, whether he had some support or not was mattering. But how does it matter that he he embarked from some port and his survivability increased? So this could have been related to either that maximum people who embarked from there, they had a family support or they were females. So it was related to something else, but not to this embark code. So I just dropped this embark code, and again, I used the same steps. I found out the same best classifier. So in this case, I got the XGP classifier, which was giving me good results for both in the train also, in the test also. So then I tuned the hyperparameters for this XGP classifier. I found out the best estimator from there. Using this best estimator, I found out. So if we see in this case, here this recall score has increased by dropping that. And the accuracy score is also similar for both train and test. So by using this, I predicted the test of given on the test data set given on Kaggle. Thereafter, I made the submission file in the same format which they had given, using the passenger ID and making a new column survive by filling it with the YPRED test. And this again I submitted. So with that, I got a score. The score increased by around 1%, and it came to around 80.143. So this was by this which I did. I can understand a lot of feature engineering can still be there. This I got for a demonstration purpose. So with this, I finished, gentlemen, and I wish you all the happy learnings. And this notebook is available on github.com on my this Lalit Naktutu _ Titanic. I have finished. If anybody has got any query, I am available. Miteji, am I audible?
Guys, if you have any queries, yeah, guys, if you have any queries, please do ask.
Lalit, Praveen here.
Hi, Praveen.
I don't have any query, but the whole session was fantastic. Actually, there are so many things that we got. There are so many insights of this project that we got. So thank you so much for this session.
Thank you. Thank you so much. Thank you so much.
Lalit sir, this is Anji. Thank you, sir. It's a really nice. Learned so many things this presentation.
Yeah,
Thank
I
you, sir.
think. I think thanks, Lalit sir, and thanks everyone for attending this session. I hope everyone has gained something out of this, and Lalit sir has really covered a complete data science life cycle. And the most important part is he has stressed a lot on that EDA activity. So the more we stress on that EDA activity, the more we gain that insight. So that's how he demonstrated basically doing that a lot of EDA. Then we come to know what all we have to do it in that feature engineering and feature selection part of it. Again, he's done completed feature engineering part, all the steps in that feature selection, filter part, embedded part, wrapper part, and then that modeling part. So whatever that models available for that classification, so he has covered all of them model and then compare and then actually presented the result and submitted the result to the Kaggle. I think that's the correct approach basically we have to follow for each and every project.
Hello, hello, Lalisa.
Hi, buddy.
Hi, Kshitij here.
Hi,
Sir, do you have any advice that you discovered while doing it? Give?
Chitiz, I can hardly hear you. If you can be slightly louder, please.
Hello, now.
Yeah, I can hear you.
Do you have any advice for us that you discovered during this project?
Oh, okay. One major thing which I realized was during the feature selection. There is no method which can give you the best columns. So it is the hit and trial. It can give you the brief insight. Yes. So it is your intuition. It is your business understanding, and that model, that feature selection is giving you some hint, but you have to try out many times, and where you are getting the best results on your test data, that will give you an indication that these features are working or not. So that I realized during this project. Thank you.
Okay, it was very good session, sir. Thank you. Thanks a lot.
Thank you, sir.
Yeah, Kshitij,
Hi,
to answer
Lalit
to
sir.
it, one more thing. Every time you have to start with that filter step. So once that filter part means as sir has started at variance threshold to find that constant, fuzzy constant, then that correlation part, that's a very, very important part. Then you have a choice for embedded part or a wrapper method. But but embedded method really it provides a good result. Only thing is there are three steps over there. So whenever you are using XGBoost, then if you try tree importance, so it might give you a better result. So that's how basically you can make a call.
Okay. Okay. Thanks, sir.
Hello, Lalit sir.
Hi, buddy.
Hi, it's Sagar here.
Hi,
Actually, the
Sagar.
session was awesome. Just if I go with the notebook and if I execute the code and if I have found some difficulty, how can we reach you to?
Yeah. That WhatsApp number is there on the WhatsApp group, so you can WhatsApp me.
Okay.
Okay, you can post on the group,
okay,
like a WhatsApp group, our group. I'll come back to you so that everybody gets the benefit.
Sagar, I have
Okay,
shared
actually, I'm
it.
not a member of the group.
No worries. Just share, Sagar. You can share us the number. I can add you in that our community group. You can drop us a mail at any time. So email ID is coffee@codingness.in.
Okay. Okay.
Okay,
Thanks a
gentlemen.
lot. Thanks a lot, sir.
Thank you so much. Happy learnings and happy
Yeah.
learnings.
Thanks
Thank you.
everyone.
Yeah.
Thanks for
Thank you.
your
Thank
time.
you.
Thank you, sir.
Thank you, Mitesh. Thank you.
Thanks everyone.
Bye.
Thank you. Thank you very much, Mitesh.
Thanks.